Good morning, everyone. Today we'll be presenting our research with the title Neural Network Model to Generate Standard Penetration Tests, SPT N-Values of Malabon City, Philippines. I am Engineer Joenel Galupino, Academic Service Faculty, Laboratory Coordinator of the Department of Civil Engineering, and my advisor, Professor Dr. Jonathan Dungca, full professor from the Department of Civil Engineering. So our first question is, why do we need to know the subsurface condition of a location? First, for planning and design of geotechnical construction project, and as per Hu et al., geomaterials can have different properties at different points on a given site due to complex geological formation phase. It can also be used for policy making and disaster risk reduction and management, or DRRM. As per Halligan, Hester, and Thomas in 1987, unforeseen site subsurface conditions resulted to hundreds of millions in claims each year. That is why characterizing an area gives a huge benefit to all the stakeholders. So how do we gather data? In gathering the subsurface condition of a location, we need to determine the location and thickness of soil and rock strata. We need to determine the location of groundwater table, along with other important groundwater-related issues. We need to recover samples for testing and evaluation. We need to conduct tests either in the field or in the laboratory to measure relevant engineering properties. And we also need to define special problems and concerns. The most common method of exploring the subsurface condition is to drill a series of vertical holes in the ground. So our next question is, how many? As per our National Structural Code of the Philippines, or NSCP, Requirements Section 303 Foundation Investigation, foundation investigation shall be conducted and a professional report shall be submitted at each building site. For structures 2 stories or higher, an exhaustive geotechnical investigation shall be performed to evaluate in situ soil parameters for foundation design and analysis. The minimum required number of boreholes per structure-based footprint is summarized in Table 303-1. For structures with a footprint area less than 50 square meters, you are required to conduct a borehole of at least 1. For structures with footprint area less than 500 square meters and greater than 50 square meters, you are required to have a borehole of at least 2. And for structures with footprint area of greater than 500 square meters, you are required to use this equation to determine the number of boreholes required. You need to add 2 plus the area or your footprint area divided by 1,000. It is rounded up to the nearest integer. So in a geotechnical borehole log, these are the most common parameters gathered. We have the name of the project, the drilling method, the location in terms of latitude, longitude, or northing and easting, borehole depth, ground elevation, groundwater elevation, and values, fines content, or the grain size distribution curve, soil type and soil description, Atterberg limits, and others. But what is the most important parameter? The most important parameter is the N-value. How important are the SPT N-values? Of course, it is used for bearing capacity. However, SPT N-values can be correlated to other geotechnical parameters such as cohesion, undrained shear strength, relative density, angle of internal friction, degree of saturation, shear wave velocity, unit weight, Young's modulus, pre-consolidation pressure, and over-consolidation ratio. Can we use SPT N-values to characterize an area? Of course, we can use SPT N-values. We can characterize an area based on these parameters. For example, we can characterize if the area has cohesive soils, okay? If the unit weight is large in this area, and we can also determine how strong the soil properties of an area if we have the angle of internal friction. But first, we need to determine the N-value first. As we have said a while ago, soils and rocks are natural geomaterials, and a variety of spatially varying factors influence their properties during their complex geological formation phase. As a result, geomaterials or geotechnical materials, geological materials can have different properties at different points on a given site, as mentioned by Hu et al. In their journal in 2020. Because of that, it would be very expensive to characterize an area since it would require numerous exploratory borings. So by creating models that produce soil parameters for a known site, geotechnical engineers would accurately predict the soil parameters they will encounter at their target locations. This is where machine learning comes in. Machine learning will play a significant role in developing these models because it will learn by the soil data, recognize patterns, and it can make decisions with minimum human intervention. Machine learning can also automate the models of soil data processing. These are just examples of application of machine learnings in the local studies in the Philippines. In 2019, we were able to publish the Quezon City soil profile reference. So what if we apply machine learning in an area in Metro Manila? Of course, as what I have mentioned a while ago, we were able to apply it in one city in Metro Manila. As an example, the soil profile of Quezon City, Philippines was generated using machine learning, specifically the KNN or K nearest neighbor algorithm. The model created soil profile that can assist engineers in determining the appropriate form of foundation for a specific site and will be used for disaster risk reduction or DRR planning to minimize ground-related disasters. It can also be used for government zonings and policymakers for land use purposes and for real estate industry as an initial guide before investing. So for our research local, we will use Malabon City. It is situated in the northern sector of Metro Manila. It is a thriving city that is bounded on the north by the city of Valenzuela, on the west and southwest by the city of Navotas, and on the east and southeast by the city of Caloocan. The city's ongoing physical expansion and structures are being built to house many development. And as previously mentioned, soil explorations are prerequisite to these projects. However, these subsurface explorations, which often involve borings, are very costly. Because of that, this study will use machine learning, specifically neural network, to estimate the representative soil penetration test or SPT N-values of each Malabon City barangay. Accuracy rate and root mean square error was also used to validate the complete performance of the model. So for our methodology, borehole data from previous research or from construction companies conducting borehole tests in each location was used in this study. Borehole data were also collected in the surrounding areas of Malabon City to ensure that the data are well sparse in the research local. The location of the study covers an area of 15.71 square kilometers. It comprises of 21 barangays, which are converted into 26 zones. The centroid of each zones were determined using Geographical Information System or GIS. Borehole data that were extracted were formed in a format compatible with Microsoft Excel, and MATLAB were used for programming. These parameters were then processed using machine learning, and the model will be implemented on a zoning level. So for our machine learning model, we use neural network model. When doing a drilling survey within a short bidding period for contracts, it is very challenging to execute a comprehensive drilling survey due to obstacles such as licensing, time, expense, equipment access, and civil complaints. To address this, technology is necessary so it can assist the properties of a site without even drilling. And it can also use a limited minimum ground measurement data. So in this study, one of the artificial intelligence approach, which is the neural network, was used to predict the value of N-value. Because machine learning is important because it produces model capable of analyzing larger, more complex data sets and generating more accurate results more quickly, even on a massive scale. So for accuracy rates, the accuracy rate for the machine learning model was gathered for validation. Accuracy rate is a ratio of the number of correct predictions to the total number of input samples. We also use root mean square error, which is the square root of the mean of all errors squared. However, in this study, hyperparameters were not tuned. For our results and discussion, 19 borehole logs were used for data processing. A total of new 26 data points or locations were generated using geographical information systems and were processed and were modeled using the neural network to estimate the subsurface layer of each Malabon zones in terms of SPT. These data layers were then embedded in the various spots shown in this figure. We used accuracy rates and the root mean square error for validation. We were able to garner an accuracy rate of 70% and a root mean square error of 7.67. This figure shows the SPT N-values gathered in situ. And this figure shows the SPT N-values generated by the neural network. It can be noticed that Malabon can be divided into two zones, the upland and the lowland, or the coastal area. With the uplands, it can be noticed that there are higher value of N value, while the coastal areas have a predominantly lower value of N. Okay, because I think it can be inferred that Malabon can be caused because of Malabon is a low-lying flat terrain that is prone to flooding, especially on the coastal areas during high tides, heavy rains, and when river and dams overflows. Also, we also checked the flood map of Malabon City, and Malabon's enduring image is its proximity to the bounty of the sea. Okay, this image is made even more aqueous by the presence of three major rivers, the Malabon River, okay, Itinajeros River, and the Tulyahan River that traverse the city. Okay, as a validation, there are two zones that you have noticed that have a grouping of N values. So we have the upland and we have the coastal area. With the uplands having a higher value of N, while the lowlands, which is prone to flooding, or the coastal area, which are prone to flooding, have a dominantly lower value of N. Okay, so for us geotechnical engineers, if the coastal areas have a lower value of N, it would require a deeper foundation because of this. Also, we use the soil profile map of JICA. The top layer of Malabon area is alluvium. Alluvium is a loose soil or sediment that has been eroded and suspended in flood or river water prior to being deposited. Thus, will provide a lower N value. Alluvium material is unconsolidated. That is, it is not formed into solid rock and can be picked up or eroded by running water and carried away before being deposited somewhere where the water flows. For our conclusion, soils and rocks are natural geomaterials and their properties are influenced by a range of spatially changing causes during their complex geological formation phase. As a result, geomaterials can exhibit a range of qualities depending on their location inside a specific site. This study utilized machine learning, primarily the neural network model, to estimate the typical soil penetration test or SPT N-values for each Malabon city, barangays, or zones, providing engineers with a baseline for determining what to expect on the subsurface at a particular project site. 19 boreholes were used for data processing. A total of new 26 data points were generated using geographical information system And the neural network model was used to estimate the subsurface layer of each Malabon zones in terms of SPT N-values. 70% accuracy rate was obtained. Additionally, a root mean square error of RMSE of 7.67 was established. It is worth noting that Malabon City was grouped into two zones based on their predicted N-values, the upland and the coastal zones. The upland have a higher N-value and are not prone to flooding, where the coastal areas have a significantly lower N-value. And due to the existence of alluvial deposit, poor ground conditions may necessitate the building of a raw foundation or deep pile foundation. And that's it. Again, it is our pleasure to present our paper with the title Neural Network Model to Generate Standard Penetration Tests or SPT N-Values of Malabon City, Philippines. I am Engineer Joenel Galupino, and together with me is my advisor, Professor Dr. Jonathan Dungca, and we are from the Department of Civil Engineering. Thank you very much.